Alright there, YouTube. Welcome back to the channel. Today we got my 89 Toyota pickup here again. And a few days ago my heater fan quit working. Now, in some places a heater fan might be optional. Here in North Dakota, it is not. So anyway, I've already found the problem and done a temporary solution. Today we're going to actually fix it. And I'm going to show you how we fix it, where the problem was, and how to find it, as well as what I believe is a design flaw. Now, a lot of people will say that these, early Toyota pickups in the 70s, 80s, 90s were some of the most durable, most indestructible things that were ever made on this planet, and I don't really feel that that's the case. This truck's got just shy of 300,000 miles on it. The original motor was rebuilt twice. And here's the connecting rod from the last time the original engine went out on this thing. It's now got a different motor in it, and it's on its second transmission. So by today's standards, I would not exactly consider that indestructible. But the beauty of these trucks is their simplicity. They are super simple trucks. There's nothing to them. They're super basic. They're really easy to repair and maintain, which makes them cost effective to keep them going for a very long time. Although the majority of these things rusted out and are junk now. But if you happen to have one like I do that has not succumbed to being rusted out, they are great trucks because they are super simple. Now, keeping in mind that the simplicity is the best thing about these trucks, you'll see why I kind of think that this is a design flaw when we get into it here. So anyway, without blabbing my mouth anymore, let's go ahead and get into it, and I'll show you where the problem is. Now, if we come into the interior on this truck, you can see my heater fan working right now, but that's because I have bypassed the issue. However, the key is off and the fan's still running, so that's definitely not a permanent solution. I already ran the batteries dead on this once by getting out of the truck and shutting it off with the heater fan still going, just kind of forgetting about this issue. So the issue is this relay right here. This is the relay for the fan, and it went bad. The contacts burned out in it. I took the original one apart and looked at it, and the contact was completely burned out. Now, I've been working a bit on getting the shop cleaned up and ready for winter projects and stuff here, and I already threw it out, so I can't show that to you. I will take apart a standard automotive relay and basically show you how this works. But this does take a special relay. I had to order one of these. Probably could have got one local, I'm guessing same day, but I just ordered one online and had it in a few days, so we've got this to put in. Now, the design flaw that I spoke of has to do with, I went all over this whole truck. There's one fuse panel under the kick panel here that has a bunch of fuses and stuff in it. There was nothing for HVAC in there. There's another fuse box under the hood, about a foot or so forward of the firewall, up on the inner fender there. There's a fuse box and some relays there, and there's nothing for the HVAC system there either. Now, as I was going around this truck trying to find the issue, I could click the switch on and off, and I could hear something clicking up underneath the glove box here, but the fan was not coming on. So we're going to go ahead and remove the glove box here, where there's a couple screws down on the bottom. Looks like there was a couple screws up here that are missing. Probably try to find some screws to fit in there. Let's see. Come on now. There we go. All right. So now with that removed, buried way up in here is a fuse for the air conditioner clutch and for the fan, and also the location for this relay. And those are the only fuses in this location. So for something that the beauty in it and the appeal to it is its absolute simplicity, why they couldn't have moved those fuses and this relay 1 foot forward and put it in an already existing fuse box is kind of beyond me. Let alone the fact that you have to take the glove box out in order to even get to this, and those are the only things in this location. So that's I would definitely consider that a design flaw. Now my temporary bypass for this is just a jumper wire. Now if you look at the relay here, we've got 2 big pins, and that's basically all I've done here is I jumped power across those 2 big pins. So we should be able to go ahead and plug this relay back into that location there. Okay, good. So the key off, we don't have a fan. Let's go ahead and turn the key on. And our fan and fan switch are now functioning. So that was our issue. So we can go ahead and get this put back together here. Got a couple push lock pieces here. Okay, so that's snapped in place. Get our screws put back in. Alright, so that repair is done. I'll go ahead and I'll take a relay apart and kind of show you guys what happened and how a relay works for those that are interested. Okay, so here's a relay here. A lot of times these will be resin bound and you can't really pop them apart like this, but this one you can. I also don't really like that they used a special relay, whereas a standard relay would have worked just fine. But you guys all remember the experiment from elementary school where you take a steel nail and you wrap a copper wire around it and you hook a battery up to it and it makes a magnet. It's an electromagnet. It's you know, something that's fairly common. And you see that we have the same thing inside of a relay. We have a steel pin here with copper wound around it, and we've got contacts here that connect from a negative side to a positive side to switch this relay. And then this one's also got a normally open and a normally closed contact on it. So right here are your contacts. Right now it's in the normally open, and then or normally closed side. So this pin here goes when the relay's not energized. There's 2 pins here that are connected through this contact, and then when you energize this coil, which takes a small load, it then will move this and it contacts this other set of contacts right here and completes that circuit. So essentially what you're doing is you're using a small amount of current to activate this magnet to switch a larger amount of current through a mechanical contact. And basically what happened is this contact, just over time of making and breaking that connection, it got burned out and it actually got hot and melted the contact away in the relay on that is what happened. Sometimes when you can take these apart, you can come in here, because you get a little carbon trace or whatever that sometimes will prevent the contact from switching. And you can just get in there with a little piece of sandpaper and clean it up, kind of like you'd do a set of points for you old school guys that even know what points are anymore. But you can get in here and file them down and get them to make good contact again. Like I said, a lot of times these relays are resin bound, so you can't really open them up without destroying them. But anyway guys, that's all I got for you for this video. Be sure to like, comment, subscribe down below, and we'll see you on the next one. Thanks, have a great day.